Imagine for a second, you are tracking a severe, like a potentially dangerous behavior in a clinic.
Right, something high stakes.
Exactly. And you collect the data for weeks, the math adds up perfectly, the chart shows this incredible downward trend, and based on that, you finalize the treatment plan.
You're feeling pretty good about it.
Oh yeah, you tell the parents the intervention is a massive success. But there is just one problem. The data you are looking at is a complete optical illusion.
Which is terrifying.
Right. The behavior hasn't decreased at all. You are basically looking at an artifact.
It's a terrifying scenario, and I mean, it happens far more often than we like to admit in this field.
Yeah.
You can have the best intentions, the sharpest clinical skills, and still be completely misled by the very tools you use to measure reality.
Well, welcome to another custom-tailored deep dive. We know you are constantly learning, constantly trying to cut through the noise, and today we are promising to clear up a notoriously tricky but absolutely vital area of behavior analysis.
It really is the foundation of everything we do.
It is. We are talking about the mechanisms of measurement, so we're going to decode the differences between validity, reliability, and accuracy, and unpack exactly how interobserver agreement works.
Yeah, this is a topic that every practitioner wrestles with,
Yeah.
whether you are prepping for a board exam or sitting in a clinic trying to make a breakthrough with a client.
For sure. Today's deep dive is inspired by the BCBA C.8 task list item, which is evaluating the validity and reliability of measurement procedures. And our source materials today come directly from the Behavioral Intelligence Mara Sánchez deep dive, along with some highly comprehensive materials from Amethyst Therapy Services.
Really great resources.
Oh, absolutely. Our mission today is to explore real-world situations where measurement validity is compromised, share some specific exam tips, and reveal why accurate measurement isn't just like an academic hurdle.
Right, it's critical for actual treatment decisions.
Exactly. Okay, let's unpack this.
So to really evaluate data, I mean, we have to start by tearing down the assumption that numbers inherently equal truth.
Yeah, that's a good way to put it.
Yeah, because before we can even begin to compare our data with other observers, which is what interobserver agreement or IOA is all about, we first need to know exactly what we are measuring.
Right.
We have to look at the three foundational pillars, which are accuracy, validity, and reliability.
Okay, let's take these one by one, starting with accuracy. I feel like this one feels the most intuitive, right?
It is, yeah. Accuracy simply means that the measured value matches the true value of what actually happened in the environment.
Right, and the sources use a great visual for this involving Dora the Explorer.
Yes, I love this example.
It's so clear. Let's say Dora is out on an adventure, and she crosses exactly 435 bridges. That 435 is the true, undeniable, objective value.
The ground truth.
Exactly. So if you are trailing behind her with a clipboard and you record that she crossed 434 bridges, your measurement is highly accurate. It is extremely close to the true value.
It reflects reality.
Yeah.
But accuracy alone doesn't mean your measurement is useful. And that brings us to validity, which asks a much more difficult question. Are you measuring the relevant dimension of the behavior you actually intend to change?
The operative word there being relevant. Like, you could have a perfectly accurate count of something that is completely useless to your clinical goal.
Precisely. Let's look at a clinical example from the sources. Suppose you want to track how often a client orders pizza independently.
Okay.
If you choose to measure the rate of pizza ordering, say, you document that it happens twice a month, that is a highly valid measurement.
Because it captures the frequency of the behavior over a time period.
Right, you are measuring a dimension that makes sense for that specific behavior. But what if you decided to measure the latency of ordering pizza?
Okay, so latency being the literal amount of time that passes between a specific starting stimulus and the onset of the response.
Right. Think about the mechanics of that in this context. Measuring latency for ordering a pizza is entirely invalid because there is no relevant, controlled starting stimulus to measure from.
Oh, I see.
Yeah, nobody is sitting in the client's living room holding up a flashcard that says, order pizza now, and then starting a stopwatch to see how long it takes them to pick up the phone.
Right, ordering pizza is a spontaneous, self-initiated behavior.
Exactly.
So even if your stopwatch is calibrated to the millisecond and your measurement is 100% accurate, the data is invalid.
Yep.
It
Yeah.
doesn't actually tell you anything meaningful about the behavior you are trying to understand.
And that leaves the third pillar, which is reliability. Reliability is simply about consistency.
Okay.
It's the ability to get the same results across repeated measures. Think about a standard bathroom scale.
Sure.
If you sip on it 3 times in a row, it gives you 150 pounds, then 150.2 pounds, then 150.1 pounds. That scale is reliable.
Because it's giving you a consistent read regardless of whether that read is actually your true weight.
Exactly.
But if you're listening to this and thinking, well, if my data is highly reliable and highly accurate, I must be in the clear, you are falling into a massive clinical trap.
Oh, huge trap. What's fascinating here is that reliability does not guarantee validity. You can have incredibly reliable data that is essentially a complete fabrication of the clinical reality.
Right. Let's put that into perspective with the nose-picking example from our notes.
Oh yeah, this is a great one.
Imagine you are observing a child, and the target behavior you want to reduce is nose-picking. You set up your observation, and every single day you consistently record 8 to 10 hand-to-face movements per session.
So the data is highly reliable. It is consistent day after day, session after session.
Right.
And let's say your count is perfectly true. You didn't miss a single instance of a finger going to the face. So your data is also highly accurate.
But then you change your vantage point. You walk to the other side of the room, you observe the child from a different angle, and you realize the child isn't picking their nose at all.
Nope.
They're picking at a scab on the side of their cheek.
You measured the wrong thing entirely because your initial vantage point obscured the true topography of the behavior.
Topography meaning the literal physical shape and movement of what the client is doing.
Exactly.
So you can have highly reliable and accurate data that is completely invalid. It's like asking someone for their name and they give you their exact birth date.
Yes.
It is accurate information, it is reliably their birth date, but it is completely invalid for the question you ask.
That is a perfect analogy. And if you build a behavioral intervention plan around that invalid data, you are trying to solve a problem that doesn't actually exist.
Wow. Okay, so we've established that you can have perfectly reliable and accurate data that is completely invalid.
Right.
But let's say you do get it right. You are measuring the correct behavior, the relevant dimension, and you have a clearer view of the topography. You are still not safe.
Not at all.
Because the very tool you use to measure the behavior can actually create optical illusions in your data.
And in the literature, we call these optical illusions artifacts. An artifact is data that appears to exist solely because of the way it was measured.
Okay, so it's not a true reflection of the behavior.
No, it's a byproduct of your measurement tool. And this becomes a massive issue when we introduce discontinuous measurement procedures.
Okay, let's define discontinuous measurement clearly for a second. Continuous measurement means you are recording every single instance of a behavior during an observation period, right?
Right. And discontinuous measurement means you are only taking samples. You break a session into intervals, say 1-minute blocks, and you only record a sample of the behavior during that block.
And the sources point out that each type of discontinuous measurement produces a very specific type of artifact.
They really do.
Let's break down the mechanics of this, starting with partial interval recording. In this method, if the behavior happens at any point during the interval, even for a split second, you mark the entire interval as an occurrence.
Okay, let's think about the math at how that creates an artifact. Imagine an interval is 60 seconds long.
Okay.
You are tracking a student tapping a pencil. In that entire 60 seconds, the student taps the pencil for exactly 1 second.
Just 1 second out of 60.
Right. But because you are using partial interval recording, your rule says you must mark a yes for that entire block.
Oh, wow. So you are taking 1 second of reality and expanding it into 60 seconds of data. You just fabricated 59 seconds of behavior that never happened.
Which is precisely why partial interval recording naturally overestimates behavior.
Right.
If you use it to measure a student's attending behavior in a classroom, and they zone out for 55 seconds, but look at the teacher for 5 seconds, you mark that interval as a yes.
So your final data sheet is going to make it look like they are a stellar focused student when they are actually staring at a ceiling tile most of the time.
Exactly. And whole interval recording does the exact opposite.
Right, because for whole interval recording, the behavior has to occur for the entire continuous duration of the interval to be counted.
Yep. So if that student attends for 59 seconds, but looks away for 1 single second to check the clock, you have to score that interval as a non-occurrence.
Oh, man. You just erased 59 seconds of great behavior. It completely underestimates reality.
It really does. And then there is momentary time sampling.
Okay, how does that one work?
This is where you only look up at the exact end of the interval to see if the behavior is happening right at that second.
Just at the end.
Right. If you check in at the 60-second mark and the behavior is happening, you score it. If not, you don't.
The sources note this is highly invalid for short-duration behaviors. Like,
Yeah.
if you are trapping something like a quick aggressive outburst or a short tantrum, checking in only at the end of a 5-minute interval means you will likely miss the behavior entirely.
Oh, absolutely. The tantrum could happen from minute 1 to minute 4, but because the child was calm at minute 5 when you looked up, your data says the outburst never happened.
And that is the artifact.
Yeah.
Your data will show a perfectly calm child simply because the outbursts happened between your momentary checks.
Exactly.
So mechanically, discontinuous measurements are just a series of deliberate flaws. They overestimate, underestimate, or totally miss the behavior.
Pretty much.
So my question is, if discontinuous measurements cause so many artifacts, why don't we just use continuous measurement for everything to be 100% accurate?
Well, because we have to operate in the real world. Continuous measurement requires a practitioner's undivided, unbroken attention.
Right.
If you are a single teacher juggling a whole classroom of students or a clinic director managing a busy floor, it is physically impossible to continuously track
As
everything.
if you're staring at a stopwatch all day.
Exactly. You would never be able to actually teach, intervene, or interact because your eyes would be permanently glued to a clipboard.
Okay, so discontinuous measurement is a necessary compromise. You are essentially weaponizing the flaw in the measurement.
I like that phrasing, yes.
Like, if you know partial interval overestimates, you deliberately use it for a behavior you want to eliminate. That way, the data forces you to be strictly conservative before you can officially declare the intervention a success.
That is exactly how practitioners use these tools strategically. You factor the artifact into your clinical judgment.
But because human observers are vulnerable to all these optical illusions, not to mention simple fatigue and bias, we can't always trust a single source of data.
Definitely not.
We need a believability check. We need a second set of eyes to prove our data is actually solid. Enter IOA.
Yes, interobserver agreement. This is the gold standard for proving your data isn't just a figment of your measurement system.
Right.
IOA is defined as the degree to which two independent observers report the same values after measuring the same events.
And the magic threshold the field looks for is 80% agreement across 20 to 30% of your total sessions.
That's the gold standard.
The sources are very specific about the formulas used to calculate this, and they issue a massive warning about the crudest method, which is total count IOA.
Yeah, you have to be careful with this one.
To calculate total count, you just take the smaller count recorded by one observer, divide it by the larger count recorded by the second observer, and multiply by 100.
And it is crude because it completely ignores when the behavior happened. It only looks at the final tally. Let's say we are observing a 50-interval session. Observer A watches closely and sees the behavior happen 25 times in the first half of the session.
Okay.
But observer B falls asleep for the first half, wakes up, and sees the behavior happen 25 times in the second half of the session.
Oh, wow. If you run the total count IOA formula, you divide 25 by 25 and get 100% agreement.
Exactly. But they actually had 0% agreement on when the behaviors occurred. They were looking at completely different events.
That's wild.
That is why total count proves you both know how to count to 25, but it absolutely does not prove you saw the same instances of behavior.
So here's where it gets really interesting. Practitioners get themselves into trouble here. They recognize that total count is flawed, so they assume stricter is always better.
That's a common trap.
They default to the total opposite end of the spectrum, which is exact count per interval IOA.
Right.
In this formula, you only count the intervals where observer A and observer B had 100% perfect agreement on the exact number of occurrences.
So if observer A recorded 4 instances in interval 1, and observer B recorded 3 instances, that interval is a 0 for agreement. It's all or nothing.
Wait, if exact count is the most rigorous, why wouldn't we just use that every single time to be safe?
Because stricter is not always better. Exact count is so conservative that it can severely underestimate the believability of your data, especially for high-rate behaviors.
Okay, how so?
Well, if 2 observers are tracking rapid vocal stereotypy, they might be off by just 1 or 2 counts in almost every single interval because the behavior is happening incredibly fast.
Oh, I see. So they are constantly recording something like 15 versus 16 or 20 versus 19.
Right. They're highly attuned to the behavior, but they're just slightly off on the rapid-fire count.
And with exact count IOA, their overall agreement might look like 10%, making a perfectly good, highly reliable measurement system look totally flawed.
Exactly. It's about choosing the right tool for the specific data profile.
Which brings us to a major exam tip from the sources regarding scored versus unscored interval IOA.
This is a big one.
The rule of thumb is use scored interval IOA for low-rate behaviors and use unscored interval IOA for high-rate behaviors. Let's walk through a mental simulation to prove the math on why this is so critical.
Okay, let's do scored interval first for low-rate behavior. Imagine a behavior that rarely happens, like severe aggression. We are watching a client for 5 intervals.
Okay.
In intervals 1, 2, 4, and 5, nothing happens. Both observers correctly write down 0. The behavior only occurs once during interval 3.
But let's say observer A caught it and observer B looked away and missed it.
Right. If we just calculate standard interval-by-interval agreement, they agreed perfectly on intervals 1, 2, 4, and 5. They only disagreed on interval 3.
So their overall agreement is 80%.
Exactly. It looks like they have fantastic reliability.
But they completely missed the only instance that actually mattered. They agreed 80% of the time simply because they were staring at an empty room together.
Exactly. That is a false sense of high agreement. With scored interval IOA, you throw out all the intervals where both observers recorded as 0. You only calculate agreement based on the intervals where at least one observer actually scored an occurrence.
So in our simulation, we throw out intervals 1, 2, 4, and 5. We only look at interval 3. Observer A scored a yes, observer B scored a no.
And their scored interval IOA is 0%.
Wow. The math violently exposes the fact that they are not reliably catching the rare behavior.
The test of agreement becomes, did you both catch the needle in the haystack? And the reverse logic applies to unscored interval IOA for high-rate behaviors.
Right, okay. Imagine a client who is constantly vocalizing. Out of 5 intervals, the behavior happens constantly in intervals 1, 2, 3, and 4. Both observers easily mark yes for those 4 intervals.
Sure.
But in interval 5, the client is finally quiet for a moment. Observer A catches the quiet moment and scores a no. Observer B is just writing the baseline trend, assumes the vocalizing continued, and scores a yes.
Again, their overall agreement would be 80% because they agreed on the first 4 intervals, but they agreed by default because the behavior was ubiquitous. To really test their reliability, you use unscored interval IOA.
So, following the logic, you throw out all the intervals where both observers scored a yes.
Exactly.
You only look at the intervals where at least one observer noted that the behavior didn't happen. In this case, interval 5, observer A said no, observer B said yes. Their unscored interval IOA is 0%.
It forces the math to prove that the observers are actually paying attention to the subtle variations, not just going with the flow of a very common behavior.
Like, did you both catch that brief moment of quiet?
Exactly.
We spent a lot of time in the weeds today. We've talked about formulas, artifacts, and time sampling. But the Cooper text, which is the foundational text of applied behavior analysis, explicitly links all of this measurement directly to ethics.
Yeah, this isn't just abstract math.
Right. We are not just doing math for the sake of passing a board exam. We are dealing with human lives.
If we connect this to the bigger picture, the ethics code is incredibly uncompromising on this. Codes 2.17 and 6.11 explicitly state that falsifying data, fabricating results, or relying on subjective guesses are severe ethical violations.
And there is a profound clinical reason for that.
There is. If a practitioner fails to collect accurate, valid data, they are vulnerable to 2 massive, potentially life-altering errors.
The first being that you continue a treatment that is entirely ineffective.
Right.
You put a client through a demanding intervention week after week. If your data is just an artifact of partial interval recording, you might assume the intervention is working.
Meanwhile, the client is experiencing 0 benefit, and you are wasting their crucial developmental time.
And the second error is equally tragic, which is abandoning a highly effective treatment because your subjective impressions failed to notice subtle progress.
The sources give a fantastic example of this. Imagine an intervention that increases a student's reading fluency from 70 words per minute to 80 words per minute over the course of a month.
That is incredible hard-won progress.
It is. But subjectively, just visually and auditorily observing that student, you cannot feel a 10-word per minute difference in real time.
No way.
Without accurate data tracking that precise rate, a practitioner might feel frustrated, assume the reading intervention is a failure, and abandon a strategy that was actually working beautifully.
So what does this all mean? It means bad data isn't just a mathematical error. It is a failure of care.
Yes.
Relying on technicians to just estimate behavior at the end of a shift, or picking a measurement system that hides the truth, it directly harms the client.
Our technology of behavior modification is fundamentally a technology of measurement. That is the dividing line between behavior analysis and subjective guesswork.
We don't guess, we measure.
Exactly. And if our measurement is fundamentally flawed, the entire science collapses.
Well, we have covered some serious ground today. We separated validity from reliability, proving that you can consistently measure the wrong thing.
We walk through the mechanical math of how discontinuous measurement creates literal artifacts out of thin air.
We simulated the nuances of IOA formulas, proving why throwing out blank intervals saves you from false confidence. And we brought it all home by realizing the profound ethical responsibility of accurate data collection.
It really pulls back the curtain on how much intentional mathematical rigor goes into every single session a practitioner runs.
Absolutely. If you are prepping for your exams or if you just want to master these clinical applications, we highly recommend checking out the materials provided by Amethyst Therapy Services.
Look great.
They have incredible resources for mastering these specific task list items. You can find them at www.amethysttherapyservices.com or reach out directly at info@amethysttherapyservices.com.
Highly recommend.
And be sure to stay tuned for our next deep dive, where we tackle C.9, which is selecting appropriate measurement procedures.
It's the logical next step. Once you know how to evaluate the data's integrity, you have to know how to select the right tool to gather it in the first place.
But as you close your laptop today or finish your commute, I want you to leave this question running in the background. We talked about how our highly controlled clinical perception is easily skewed by the measurement tools we choose, creating literal artifacts just because we checked in on a behavior at the wrong second.
Right.
If our formal, rigorous data can be so easily distorted by the lens we look through, how many of our everyday subjective judgments about the people in our personal lives are just artifacts of our own biased sampling methods?
Oh, wow.
Are we seeing the whole picture of who they are, or are we just taking a momentary time sample and assuming we know the truth? Think about that. Until next time.